Hey guys, this is Naveen here. Welcome back to Naveen Automation Labs. So guys, today we are going to talk about most important Java interview questions, which is like very important if you're going for Java interviews or if you're going for any development profile or SDET profile or automation profile. These are the top 15, 20 questions people will ask you 100% when you are going with the Java interviews. And if you are saying that, okay, yeah, you are good in collection APIs and if you're comfortable with the hash map. So these are the important things. Please prepare for that. It's very easy, not no rocket science, but please you have to make sure that okay you are watching, you have already watched all those videos which I have already covered in okay with respect to hash map. So please try to understand and try to learn these kind of questions and answers how to give that. So the first question is that how does put method, which is the most important question that works in hash map internally, so the answer is on hashing principle. So what is hashing principle? That I have already told you that hash map will store the value on the basis of a key and the value, right? So let's see the key, whatever the key is there. The key is let's see Tom, and the value is 100 like that. So it will this is my key. So it will calculate one hash code over here. Okay, so whatever the hash code of Tom will be calculated. So let's see some number 170268, and then one integer index will be calculated that is equal to, let's see, this is my hash code. Again, this will be an integer, and then whatever the key is getting, let's see, I'm getting 4. It means inside this particular hash code bucket on fourth number, let's see, this is my 0, 1, 2, 3, and on fourth index, this particular value, what is the value? Tom will be stored over here. And what is the key? The key is okay, the key is Tom, and the value is 100 will be stored over here. So this particular node is representing what? It's representing a node over here. What kind of node? A linked list node over here, guys. So the value is whatever the value is 100, and the Tom will be stored over here, and this is the index number is 4, like that. Okay. So on the hashing principle, it will. Now the next question is that what is the requirement for an object to be, what is the requirement of an object to be used as a key or value in hash map? So it's very much clear that key and value both should use or should implement the hash code and the equals method over there, right? Why? Because this particular hash code method is coming from where? It's coming from the object class. So whatever the key that you are using it, this particular key, this key can be in a separate object, a class object, let's say employee object. That employee class should implement that hash code method and the dot equals method. So the important thing is that it should implement the hash code method. You should have the proper hash code implementation, and the dot equals method also you should have it. So hash code method is for, it will be applied on the key, okay, at the time of put, at the time of put operation whenever you are inserting the value, and dot equals method will be applied at the time of get whenever you are fetching the value from the hash map. So get method will be used, so dot equals method will be used at the time of get method, equals method will be used to check that okay the hash code of that particular key is matched or not. If the key is matched, with the help of dot equals method, it will return whatever the value is available. So that's why we are getting a value over here after that. So get method will return the value, and then hash code applying with put method will calculate the hash code of the key, and then it will calculate the index as I told you earlier, and then the value will be stored on that particular index, like that. If you're getting confused, please watch the video once again how exactly HashMap works internally. So what is the requirement of an object, for an object to be used as key or value in HashMap? So answer will be very simple. Both key, I would write a quick one line, I would say hash code and dot equals method both. Dot means yeah, simple equals method. Now the next question is what will happen if you try to store a value, store a key which is already present in HashMap. So yeah, if you store an existing key in HashMap, then it will override the old value with the new value, and the put will return the old value, right guys? So there will not be any exception or any kind of error. So yes, a duplicate keys you can write it. So what you just need to explain that okay yeah, so let's see I have already one key over here. Let's see my key is a Tom and the value is 100. So the question what exactly is asking, if you try to store a key which is already present in the hash map. So let's say I'm writing one more key over here Tom, and the value is 200. So it will not give you any error. This is absolutely allowed. So when you try to fetch that, okay, get the value of Tom, so what will you get? You will get 200. You will get the latest value. So I simply write the answer is it will return latest value on the new key. Okay, multiple same key allowed. Can you store a null key in Java? So answer is yes. So very straightforward answer. Only one null key is allowed in. Now the next question is, can you store a null value inside HashMap? So yes, HashMap allows multiple null values. You can store as many as null values if you want, and then that's it. So answer is, I would say answer is yes. It allows multiple null values, but only one null key is allowed in HashMap. How does HashMap handle collision in Java? The most important interview question. Now let's see how exactly it works. Now see, again, let's see, this is my quick hash map. At the time of explanation, you can design the same hash map like that, and you design it like this. So how many buckets initially it will create? It will create 16 buckets. Okay, n is equal to 16. 0 to 15 indexing will be created. That is a default bucket size initially for the hash map. Now let's see, I'm going to store again Tom is my key and the value is 100. So I quickly write, let's see, one more value. I'm writing Naveen over here and the value is 200, and then I'm writing Lisa over here and the value is 300, and let's see, one more value I'm writing, let's see, Peter, and the value is 400 over here. This is my hash map I really want to enter. So which operation I'll be using? I'll be using put method. I'll be calling it, and put method internally what does, it will calculate this guy, it will calculate the hash code of this guy. So hash code of key will be calculated. So let's see, it is for the Tom, hash code is something, and from this particular, let's see, 170268, I'm getting fourth key. So let's see, this is my fourth index, the value will be stored over here. It means 100 with a Tom will be stored over here. Then I'm going to calculate a hash code for Naveen, and then let's see, for hash code is coming and the index is coming on the fifth index, so Naveen will be stored over here, let's see, with 200. Then I'm writing hash code for Lisa, and Lisa, let's say I'm getting some hash code and the index is 4. It means now there is a collision, right guys? Because on fourth position, Tom is already available, and for Lisa also, I'm getting a different hash code but a different key over here. I mean, for the same key over here for the different hash code. That is possible. Multiple hash codes can have the same key. So on the fourth index, Tom is available over here. So what exactly it will do on this particular node, one more node will be attached on the same node, and that is for the Lisa. Let's see, this is for Lisa and value is 300 over here, like that. And let's see, Peter is also, now we are calculating, Peter is also getting some hash code and the value index of value is 4. So again, this particular node will be attached over here for Peter as well. Let's see, this is for Peter and the 400. So this is called collision. Collision means on the fourth index, this is also fourth index, this is also fourth index. On the same fourth index, multiple values are getting stored over there. So it will look like on the same fourth index, it will look like this. A new linked list is getting created on the same fourth index. So this is the complete fourth index, guys. So this is how it works internally. This is called collision. Collision means on the same index, multiple values are getting stored over there. So I hope you can understand this. So I'm not writing the answer, I've already explained. Which data structure HashMap represents? Anyone? So which data structure HashMap represents? So we have already seen that, okay, it's an implementation of hash table infrastructure, I mean data structure, and internally it maintains, at the time of collision, internally it maintains what? A linked list over here, like that. And one more thing you need to understand, let me quickly tell you that once these number of nodes are getting the threshold value, it means this is the first node, this is my second node, third node, fourth node, fifth node, let's see, this is my sixth, a seventh, and then eighth node. Okay, once these 8 nodes are available, after that, what exactly Java will do? Java will convert this particular linked list into a binary tree. This is called a balanced binary tree. So balanced binary tree means this is this is like that. All the smaller value will be stored at the left hand side, and all the bigger value from the root value will be stored at the right hand side like that. So it will create a binary tree, and the time complexity of the binary tree is O of log n, which is better than O of n in case of linked list. Okay, so this is the internal data structure it will maintain. So which data structure is used to implement HashMap in Java? So I think that is the same answer for this. We can say that, yeah, HashMap, same data structure like we have already seen, linked list and binary tree like that. Now the next question is, can you store a duplicate key in HashMap? So no, you cannot store duplicate keys in the HashMap. It does not allow duplicate keys. So answer is no. We cannot store duplicate keys in HashMap. But if you try to insert an existing key with the new or same value, then it will override the old value. It means what I'm saying is that it will not give you any error. So let's see, the key is like that. The key is Tom. The value is 100. Again, you write the key. Value is 200. Again, you write Tom over here, and the value is 300 over here. So like this, I'm showing like this. Tom 100, Tom 200, and Tom 300. If you write it like this is fine. I can do that. And if you try to get the latest value of Tom, so what will you get? You will always get 300 over here. Answer for this question, that okay, yeah, can you store the duplicate values in the hash map? No, the answer is no. But you can store it. It will not give you any error, but you will always get the latest value. Now, HashMap is thread safe in Java. That is the most important question. That okay, HashMap, I would say no. HashMap is, so answer is very straightforward. No, this is not thread safe, or I would say not synchronized. So HashMap by default is not a thread safe or synchronized. You have to use either concurrent HashMap or synchronized map. You have to use that. What will happen? Next question is that if you use HashMap in a multi-threaded Java application. So if you use HashMap in a multi-threaded environment, in that case, multiple threads will try to modify the map, obviously, and like add method and get method and put method, and we will try to modify the map also. Then the internal data structure of HashMap may get corrupt, may get the data might be corrupted. Why? Because see, I'll tell you what happens. Let's see, this is I'm going to create one hash map over here. Right, guys? So let's see, this is my hash map where multiple buckets are available. And this is not synchronized. It means one thread is available over here. Multiple threads are going to perform multiple actions. It could be a simple add method, and it means a put method, a get method. We will try to modify the data. This is also trying to put some values over here like that. So these are the threads. They are, attacking this particular hash map, and it's not synchronized. So let's see, this is my thread number T1, putting a value 100 over here. At the same time, thread number T2 also putting the value 200 over here. But now let's see, this is the thread number T3 is fetching the value from this particular index. Which value it will get? It might get 100 also, it might get 300 also. It depends at which thread has, what is the latest values available at the time of T3 is getting or entering in this particular hash map. So that's why the data is corrupted. At the same time, let's see, multiple threads are putting the values, same other different values are available over here in the same bucket. So in this case, the data chances are very high that okay, in multi-threading environment where multiple threads are concurrently using this particular same HashMap object, and then they might change or modify or get the value or update the value or add the value at the same time with different values. So when you try to fetch it, chances are there that okay, you will not get the latest value over here, or might be possible that okay, data got corrupted over here like that. So in multi-threading environment, HashMap, we should never use it. We have to make it concurrent HashMap. We have to make it thread safe. Then only we can do that. So the answer is, what will happen if you use HashMap in multi-thread environment? The data might get corrupted over here and will disturb the entire internal structure of the HashMap also like that. So this HashMap will be completely useless in that case. So I would say not recommended. What are different ways of iterate over HashMap? I have already covered this particular topic. Please watch that video. So 3, 4 things you have to remember. By using the key set in iterator, you can use that. Entry set in the iterator, you can use that. Entry set in enhanced for loop, you can do that. Key set in the get method also, you can use that. Or one more thing, by using a for each method with lambda also, you can do that. So please go and watch that particular video that I've already covered, that how to iterate, what are different ways to iterate an HashMap. How do you remove a mapping while iterating over HashMap in Java? So to remove the mapping, guys, we have to use a remove method. Okay, so simply use remove method. Very simple answer. Use the remove method to remove a key and value pair, right? Like that. So dot remove method, you can use that, and you can simple pass which key that you want to remove. So you can, that particular mapping will be removed over there. Next question is that in which order mappings are stored in HashMap? So in the random order, because HashMap does not provide any insertion order, it does not provide any order, or it does not maintain any order, right guys? Because the hash code that we are calculating, guys, whatever the hash code that we are calculating, see, these are the hash code, they are not fixed. Next time you might get a different hash code for a different key. So I cannot say that, okay, for a particular string, the hash map will be calculated, or what kind of, it depends what kind of implementation you have done for your hash code, right? So that's why it does not maintain any order. It's not like that, okay, Tom will be stored always at the first position or the second position. No, you never know. Okay, in the next time, the position of Tom will be changed. The position of Naveen will be changed. So it depends what kind of hash code and what kind of index are getting calculated, and then on the basis of that, it will be stored. So that's why you may get a different order every time you iterate over it. So that's why the moment I try to fetch the value from the hash map. So let's see, this is I simply store some hash map over here like that. Okay, let's see, 4 values I have entered, 1 2 3 4, and some value a b c d. Okay, so this is the value that I have stored with the help of put method. Now the moment I try to get, you might get different order. You might get 1 3 2 4. Next time you might get 1 4 3 2. You might get 4 3 1 2, like that. Okay, so every time you will get a different order. It does not maintain any order. So at the time of iteration also, you will get a different order. Can you sort the hash map in Java? So the question is that, can you really sort it? No, we cannot sort a hash map, because just like we have list is okay, order based collection or index based collection, but hash map does not maintain any index over here. So I cannot sort the hash map by keys or by values or by their key and value pair format. I cannot use that, right? So if you really want to sort it, you have to convert that into linked hash map. So the answer is, use that. Okay, so you can use linked hash map, or you can use this guy, sorted map also. You can simply do that. So by using sorted map also, you can use it. So let me just quickly write. Okay, okay. Now, what is a load factor in hash map? So load factor is a number that controls the resizing of the hash map, right? So let me complete it first. When a number of elements in the hash map cross the load factor, as if the load factor, let's say, is 0.75, and when becoming more than 75% full, then resizing trigger, which involves array copy. So what I'm saying is, let's see, by default it will create, just a second, by default guys, it will create the 16 segments over here, like that, 0 to 16, 0 to 15 over here, 0.75. This is my load factor. Okay, now how does resizing happens in HashMap? That is again the same question, that okay, on the basis of the load factor, it will okay, it will resize the array, it will resize the segments internally. So whenever that map is completely full and the size of the map crosses the load factor, for example, in this case we have seen that okay, load factor is 0.75, and this entire thing was, or and let's say becomes more than 75% full, then the resizing will be triggered. So you can define that okay, 0.75 means 75% of the hash map got full. It means somewhere it got stored over here, and 16 segments are there. Let's see, around 10 values got filled or 11th value got filled, not on the 16th value, sorry about that. The moment it will automatically trigger, it will check that, okay, what is your load factor? The load factor is 75% or 0.75. It will try to create some more segments, double the bucket also inside the memory, like that. Okay, so we can take a separate chapter on what is load factor. If you have written 100% load factor, it means once the 100% values got filled up to 15, and then okay, the next it will double the segment over here. So again, like that. Okay, so it depends what is the load factor you have written. So by default, I think load factor is 0.75, that is 75%. So how many entries you can store in HashMap? What is the maximum limit? So that is, there is no limit for HashMap. You can store as many as values or as many as key and value pair format you want to store. Okay, until you run out of the bucket. So obviously until you run out of the memory. So there is no limit for that. And which method to check? You have to use a dot size method. So answer is no limit. Okay, so next question is, what is the difference between the capacity and the size of HashMap? See, capacity is nothing that the moment we define the hash map, okay, whatever the hash map that you are defining it, so capacity denotes that how many entries hash map can store, and the size means the actual physical capacity, that how many values are already stored currently present in the hash map. For example, in this particular, let's see, I'm going to create one simple hash map over here. Okay, and physical capacity, I would say 16 over here. Sorry, this is called virtual capacity. Virtual capacity is equal to 16. It means 16 segments are available. But let's see, I have entered the value only for 4. I mean, only for up to 0 to 3 only. 1, 2, 3, and 4. So what is the physical capacity? Physical capacity is equal to 4. This is called the actual size. So when you call the dot size method, that will give you 4 over here. It will calculate how many values are actually entered over here in this particular hash map. So this is called physical capacity, and the virtual capacity means how many segments Java will create for you to store the value for this particular hash map, like that. And the next segments will be created on the basis of what is the load factor that you have given over there. So this is the answer for this question. You can see the capacity denotes how many entries hash map can store, and the size denotes how many mappings or key value pair is currently available, like that. What will happen if two different keys of hash map return the same hash code? Very, very good question. So the two could be possible that, okay, two keys having the same hash code, then in that case the collision will happen, right? And then they will be stored in a linked list order together. So how to explain this question at the time of interview? So I'll quickly show you once again. I have already explained that this is my hash map, and these are the buckets. Let's see, 0, 1, 2, 3, 4 up to 15, and the value is, let's see, for Tom value is 100, and then for Naveen I'm writing value is 200, and for other guy 300, and for some other guy 400, some other guy 500, like that. So let's see, for this guy also we are getting some hash code, and we are getting index is 4. For this guy also getting the same hash code, index is 4. For this guy also same hash code or different hash code, but the index is 4. So this is called collision, right guys? So the question was, it was asking that, okay, what will happen if two different keys of hash map return the same hash code? It means the index will be calculated same. So let's see, if your hash code is 170268, index is coming 4. For some, this is for key number 1. For key number 2 also you are getting the exactly same hash code, so obviously index will be 4. For the key number 3 also exactly same hash code, same key you will be getting it. So likewise, you have n number of keys are available, you will be getting 4 index over here for all the keys. So where exactly their respective values will be stored: v1, v2, v3, v4, and vn. All these values will be stored on the 4th index only, on this particular index only. So what exactly it will happen? The first node will come over here, then it will create one more node on the same index, one more node over here, one more node over here, like that. It will keep adding the okay, nodes over here, and it will create one linked list data structure internally. So that is the answer for this particular question. And once after JDK 1.8, remember this thing, after JDK 1.8, linked list is getting created, that is fine, but there is a but. If the threshold underscore value is equal to 8, it means total number of total number of nodes are equal to 8. When it is reaches or crossing this particular threshold value, it means from the ninth index, this entire linked list, whatever the list that we have created, right guys, it will be converted into a balanced binary tree over here, like that. So here the time complexity was O of n, and here you will get in worst case O of log n. And if you see the graph between O of n and the log n, O of n is a linear graph, and O of log n you will be getting somewhere over here like that. So this is log n and this is O of n. So which one is better? To optimize this thing, JDK 1.8, after JDK 1.8, to optimize this thing, this entire linked list into converted into a balance binary tree over here, like that, which gives the time complexity of O of log n, the big O of log n. Okay, so this is how it works at the time of collision. So what will happen if two different keys of HashMap return the same value? Collision will occur, and then it will maintain linked list internally. And you have to please note it down. Please explain this thing after JDK 1.8, after threshold value equal to 8, after from the ninth node onwards, it will be converted into a binary tree over here, like that. Perfect. So these are the guys important interview questions for HashMap. Please watch all the videos that I have already covered previously with respect to HashMap. All the videos are available on my channel, and I can show you these. Let me just, and I would strongly recommend guys that please watch these number, start from here. Okay, what is HashMap? Internal mechanism of HashMap. I have already explained with the proper animation and everything. And then try to understand what is concurrent HashMap, and try to understand the internal mechanism of linked HashMap also. That will help you a lot. So thank you so much guys. Thanks for watching this particular video. I hope uh, you are good with the HashMap interview questions, and then I'm pretty much sure that okay, you can handle any kind of HashMap questions now. So thank you so much. I'll see you in the next video with a new set of questions or new set of topics. Till then, take care, bye bye, and please subscribe to the channel and let me know if you have any issues. Thank you.